So I am Dr.S.ARUNKUMAR, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, Coimbatore. So in this video lecture, I am going to discuss about the topics on air compressors, particularly the topic reciprocating air compressor fundamentals, and also we will going to discuss the applications area. So these are the presentation overview. I am going to discuss in the topic reciprocating air compressors. Likewise, first we are going to discuss the fundamentals concept of reciprocating air compressors and compression cycles. There are three stages of cycles. One is suction stroke, compression stroke, as well as the discharge strokes, and few key terminology about the reciprocating air compressors and types of the reciprocating compressor, like a single stage lower pressure air compressor, higher pressure air compressors, and oil free compressors. Finally, we are going to discuss the applications area and design thinking concepts. So first, I am going to discuss the introduction about the reciprocating air compressors. So reciprocating air compressors are positive displacement machines that uses the piston driven by the crankshaft to deliver the high pressure air. So the atmospheric air is compressed by using the piston and machines. It convert into the high pressure air. They are critical in numerous industrial as well as the commercial applications. So this lecture explores their air compressor working principles as well as the key terminology and also some of real world significance. So this is the working principles of the compression cycles. There are three stages of cycles. First one is the suction stroke and compression stroke as well as the discharge stroke. In the suction stroke, the piston descends and creating the vacuums. That means the pistons moves from the backward to frontward and it creates the vacuum, and air enters inside the cylinder in the vacuum area via the intake valves. Then second stroke, compression stroke. In the compression stroke, the piston ascends and compressing air. Both valves are closed. Both the inlet and the outlet valves are closed. And final stage is the discharge stroke. In the discharge stroke, the compressed air exits through the discharge valve as piston continues the ascent position. So this is some of the key terminologies in the air compressor systems, that is clearance volume, volumetric efficiency, as well as the piston displacement. These are the very most important terminology used in the air compressor system. Let us discuss one by one. Clearance volume, the volume remaining in the cylinder when the piston is at top dead center. When the piston is at top dead center, there is some availability of volume inside the cylinder. It is called the clearance volume. Then volumetric efficiency is nothing but it is the ratio of actual air delivered to the theoretical displacement of the cylinder. And piston displacement, the volume swept by the piston during the one stroke and multiplied by the number of cylinders. These are some of the key terminologies followed in the air compressor systems. And some of the types of air compressor systems are single stage, two stage, and the oil free air compressor system. In the single stage systems, the compresses air in one step, ideal for the lower pressure demands. In the two stage air compressor system, it compresses the air in the two steps with the intercooling method as well as the suitable for the higher pressure applications. Finally, the oil free reciprocating compressors are designed for applications requiring air free of oil contaminations. Examples in the application areas are medical and the food industries. So some of the applications in engineering, the pneumatic tools, manufacturing, automotive, as well as refrigeration. The air compressor system is used in the following application area in the engineering field. In the pneumatic tools, powering the jackhammers, wrenches, and nail guns on the construction sites. Coming to the manufacturing field, the automated assembly, painting, as well as the material handling in factories, and automotive field, tire inflation, paint spraying, and the engine maintenance. These are the main applications area. And finally, the refrigeration system, it comprising the refrigerants in the heating, ventilation, and the air conditioning systems and the cold storage systems. So coming to the design thinking stages, the first stage of design thinking is empathize phase. Empathize phase is nothing but based on the customer reviews and customer ideas, we can find out the problem statement. So in the empathize phase of design thinking focuses on understanding the user's needs as well as some of the user challenges and the context. For example, interviewing the factory managers about the noise levels as well as observing the maintenance technicians performing repairs and analyze the energy consumption data from the existing compressors. So understanding pain points like downtime as well as the air quality. So this deep understanding forms the basics of informed engineering solutions. This is the stage of design thinking. And another one stage is ideate phase. In the ideate phase, we give the solution, we give the idea to that particular problems. Like the ideate phase is about the generating the wide range of potential solutions without judgments, brainstorming new valve designs for improved efficiency, as well as developing the concepts for modular compressor units for easier maintenance, exploring some alternative cooling methods to reduce the energy usage, and innovating sensor integration for the predictive maintenance. So quantity over the quality initially, fostering the creativity to solve the identified problems. So these problems, these identity problems is founded from the customer as well as the technicians reviews. So let us discuss one real-time case study about the optimizing the compressor efficiency. So a manufacturing plant faced high energy cost due to an aging compressor fleet. Applying the design thinking principles, that means empathize, that identified the peak load demands and common failure points and operator feedback on the existing systems. So the result, it gives the up to 25% reduction in the energy consumptions and significantly extended the equipment lifespans. So in the ideate stage, proposed solutions like variable speed drives and optimized piping and multi-stage compressor upgrade. By integrating the variable speed drives and optimized piping and multi-stage compressor upgrades, we can get the 25% reduction in the energy consumptions. So this is the summary of this lecture series, the enduring role of the reciprocating compressors, fundamental principles, versatile application, and the innovation potentials. So these are the references I have gone through for this lecture series. Thank you for watching.